Professor Joel Esposito, welcome. And thanks for making some time to chat today. I'm really excited about this conversation along a couple of lines. Uh, Certainly from your primary discipline, robotics, control systems, that's a big part of the discussion as it relates to how we envision the future in terms of great power competition. And I'm at least as excited to talk to you about your role as director of research over in the Provost Cost Center and all the things that are involved in that. That's the part that featured very prominently in our film series that we're in the process of wrapping up. And I think there's so much in there that we probably should dig through. So again, thanks for being here. Welcome. And why don't we just start with a little bit of background? How long have you been here at the Naval Academy? What is it that you principally do and teach right now? What are your passions here?
Yeah.
Tell us a little about yourself.
Well, thanks for having me on, Joe.
Yep.
It's a pleasure always. This is going to be the beginning of my 23rd year here at the Naval Academy, which is hard for me to believe. All at once, it feels like
Yeah.
it was just yesterday. But
Yeah.
and then again, a lot's happened since then. So
Right.
I came to the Naval Academy as a civilian without any time in the Navy, not quite sure what I was getting into, but I knew that I liked robotics. I knew that's what my PhD was in.
Good place
That's
to
what
be
I
for
had
that,
done.
too. Yeah.
Exactly.
Yeah.
And at the time when I came here, I was trying to understand how that might apply to a place like the Naval Academy. And when I came and visited and interviewed, I felt like I had my immediate answer to that.
Yeah.
I felt like this is a place that embraces the importance of science, technology, and then what would later become even more prominent, which is the role of robotics in the sense of unmanned or autonomous
Right.
marine vehicles, drones, and things of that nature.
Right.
So that's really my academic background. At the time that I've been here, I started one of the first courses in autonomous unmanned vehicles.
Yeah.
And that's grown in size and interest, as has the Navy's interest in that grown in size as
Sure.
well. And I've also been involved in the data science and the artificial intelligence side of things. I helped create the data science major here. So that was also something that I really believe in. And I'm happy to see the big Navy embrace those as well. And the excitement that our students have for those topics is just really a pleasure to work alongside them with that.
Yeah, I love it. So Joel, you've been at this for a while now. As you mentioned, 23rd year you're starting. And perhaps it looked a little different when you first got here. Robotics, control systems, certainly fun. The technology is moving fast even then. But now we seem to have really taken a leap. Whether it's in regard to robotics or its intersection with artificial intelligence, we've kind of hit an inflection point where the speed of things has ramped up greatly. And we're also focused on a very particular specific threat now. Perhaps that's added to the acceleration of the technology. Can you talk about anything that you might have seen over the span of your time here, especially in the last few years, and especially as it relates to this factor that tends to focus us, which is great power competition with the People's Republic of China?
Yeah, I think there's a lot of things that start out, as an idea in a lab that's interesting and exciting in its own right. It's kind of fun to play with, if you will, whether that be drones or robots. But it takes on a different level of urgency and a pace of innovation when it becomes tied to a national security concern like the great power competition. And I think about in the example of AI, right? So people had worked on these language models for a long time, and before about 2022, nobody really cared all that much, right? They were kind of regulated to some lab and kind of obscure province of researchers, right? And then all of a sudden things shift in a way that now we feel like we're in a bit of a space race with China. And that if you followed when DeepSeek came out, that was their large language model that was released and believed to be a near peer competitor to the American-made versions. And I think one of the things that it brings up, to go back to your point about maybe silos and different disciplines and different parts of our mission playing together, is to win in that race, it's not enough just for the computer scientists to get together and design a better algorithm, right? There was a discussion about export controls on chip manufacturing. So, what role does kind of political science or sanctions or policy making maybe play in that race. There's a talk about the supply chain. There's a talk you mentioned about the privacy of data, right? And that kind of gets into some of our concerns that we might have in the humanities or the social sciences or leadership ethics and law. And all these facets have to come together if you want to win. It's not enough to just
Right.
sit in the lab and play with the technology
Right.
and kind of make a better version,
Yeah.
right? If you want to win, you have
Sure.
to be, all cylinders have to be
Yeah,
firing.
sure.
at all
Success
different
won't be
fronts.
born in a vacuum here.
Right.
Yeah.
So all these people that maybe not think of as like playing a role necessarily in the AI industry are.
Yeah.
Right. Whether that's privacy protections of data, whether it's manufacturing, whether that's sanctions, whether it's trade laws and policies,
Right.
they're all playing a role there.
Right. Fascinating.
Yeah.
And on those points, Capstones figured pretty prominently into my conversation with Provost Firebaugh. Obviously, it's the thing that really gets her excited about. It's certainly at the end of the year. But from your perspective, you sponsor a lot of these things. You shepherd
I do.
a lot of these processes
Right.
that
So-
are the Capstone. Tell us about that.
Yeah, I've been part of it from both sides, from the side of helping one-on-one individual students kind of come up with their projects and work through that process.
Right.
And then I've also been on the side of helping organize Capstone Day, which is
Right.
kind of the public-facing part of that. It's a little bit of a unique experience because I joke that it's a little bit like only coming to the final exam of a course,
Right.
And that's kind of what Capstone Day is. It's the part that everybody sees. But what's really insightful, I think, is when you work with those students one-on-one on their projects. So over the years, I've sponsored and advised all kinds of different ideas. So those were ideas about unmanned boats and drones, but then there's kind of wackier one-off things. I've had all kinds of people try to make wearable fitness devices that could track different metrics about them. I have a group this year that has an instrumented soccer ball. So they have an interest in club soccer.
Interesting.
But they are trying to bring the ideas of data analytics and electronics to bear on that training. Can we get kick force out of it? Can we get the velocity of the ball, spin rate, different things like that? So it's been a really neat way to see young people merge maybe a passion for something else, whether that be an obvious Navy and Marine Corps thing, or perhaps it's a pursuit like soccer. That's a bit of a hobby. It certainly plugs into the physical mission, but it's not unique to the Navy. But still, to try to marry that with their academic interest, which in my case, being in that department was computing and electronics and robotics and so forth. And what's really neat about it is, there's this period in the beginning where it's, for a lot of them, it's the first time that they've had to define the problem.
Right.
Yeah, there's a saying by this science writer, Roger Lewin, that says, too often we give our children answers to remember instead of questions to ask. And I'm sure in your space,
Socrates would be proud.
It's all about the question, right? But very often in these technical fields, it feels like, or the format they're often used to is, here's the question and there is a right answer.
Right.
Part of this Capstone process is just to decide what the question is, right? You want to make an instrumented soccer ball, you want to make a drone. Well, now you have to think through what are the requirements, how could it be used, right? You have to maybe talk to potential users of it and get their insights into it. Maybe the way you envision it being used is not how that consumer or the operator in the field might be envisioning it. So you have to build all those things into it. And there's a period there in the beginning where I think they're a bit uncomfortable with it. And I think that's a good experience, right? To kind of wrestle with these questions and not have anyone to tell you what the right answer is, right? So they have to explore it from different sides.
Yeah.
Is it manufacturable? Is it usable? Is it technically feasible in the time they have available?
I think at the heart of a lot of that is something that perhaps we all discovered in this film series on great power competition, that creativity may be one of our competitive advantages.
Absolutely.
There's something about American culture, there's something about our educational system, perhaps, that makes us curious, hopefully, at our best at least. We're very curious about solving problems and asking powerful questions. And you've formatted this and formalized this in a way. Could you say a few words about creativity and how we might cultivate creativity and a creative mindset, maybe even an entrepreneurial
Right.
mindset in our midshipmen today? And how has that changed? Because you've been here quite some time. How has that changed over the years?
Yeah. Well, I really like the word creativity, because when I describe to people my job, my role as an academic, as a researcher, as a professor, I describe it as a creative pursuit.
Right.
Most people think of that in the context of maybe the arts
Right.
or performance or something. I don't think of that as a creative pursuit.
Yeah.
But it's easy to forget the word, creative
Right.
is to create, to physically create. If
Yes.
you build something, if you go in your workshop and you build a wooden table, you are a creator.
Right.
And that extends to a lot of things. If you write a piece of computer code, you are a creator. You have created something. So it doesn't have to mean creative in the sense of, artistic endeavors, right?
Right.
It's the act of physically bringing something into being.
Right.
And part of the reason that's so powerful is that it forces you to think through things that a pure pencil and paper exercise could never alone
Right.
address,
Right.
right? You're forced to confront questions that maybe you didn't anticipate,
Yeah.
or new things arise in the process. And I feel that it unlocks a part of your brain that
Sure.
you don't get when you
Sure.
passively learn. Like, say, when you read or you watch media, you don't get that.
Yeah. You may be directly addressing perhaps a stereotype many people have first about the military. This is a service academy,
Right.
That the military somehow doesn't necessarily prize or even appreciate creativity. And secondly, you mentioned that you're here because of your passion for science, technology, engineering, mathematics. They don't associate that with creativity either. As you say, they usually the creative arts, so to speak, sculpture, painting, whatever. But those things are deeply tied together, creativity and these pursuits that you're after. Can you talk about maybe some of the great success stories you've seen? You've already given us some examples from the Capstones right now, but just generally speaking, getting people to rethink their preconceptions about this place, about the military, as it regards creativity.
I think there's two pieces of that. I think there's in the sense of what we do maybe in the classroom.
Yeah.
And, and I think for all the military, I'm sure this is true, but I feel that for the Navy, with the concept of command at sea, it is so often that there isn't someone right there to tell you the right answer. You can't get that immediate
The master and commander thing, well away from the flagpole.
Exactly.
Yeah.
So that you'll often have to improvise a solution or adapt a solution. And all you can draw on is your experiences and some first principles and the team that's around you.
Yeah.
Right. And in the process of doing that, you're most likely addressing a situation that has never been addressed before. It's like a man can never walk through the same river twice. Right.
Yeah.
So it's in that way, you are creating a new solution right there on the spot. And it's on you and your team. And I'm sure it's nowhere more obvious than command at sea or under the sea.
Right.
I mean, these are things that call for innovation and improvisation.
I love that. And that kind of segues us into the larger point of all of this, right? We hire all of our graduates. We know exactly what they're going to be doing. This 47-month preparation here in Annapolis has got an end point in mind. It's commissioning as well as graduation. You do a lot of kind of feedback systems, full loop systems with the fleet as well. Can you describe some of that? I think this falls under you wear multiple hats, but the hat that you wear as director of research. Could you talk about how this serves that larger purpose and serves the fleet at the same time it serves the educational outcomes associated with an academy education?
Yeah. So you made a joke about the feedback or closing the loop. People have probably heard that term before, right? So that's kind of a reference to one of the aspects of robotics is what we call a control system. So a control system might be your cruise control on your car. Right. It's you set a speed, and it's constantly taking a measurement of your car's actual speed, and then taking some kind of corrective action and feeding that back to try to maintain that speed. So there's this constant feedback loop, right, where you're taking a measurement or assessment and then using that to adjust course, so to speak. Right. And the analogy plays over to Many things, right? So it could be the case of our curriculum here at the Academy, our core curriculum. We don't want to be still teaching gunnery and steam in the way that we did in 1910,
Right.
because the world has changed and the needs of the Navy has changed.
Right.
So if you just do that in the blind, or what we call open loop, you just keep doing the same thing over and over, you're going to lose a connection to the needs of the Navy.
Sure.
And in a lot of ways, what our research enterprise here too, and a lot of people maybe don't realize, they think of college professors as people who primarily teach classes, and that is our most important role here. But faculty have their own scholarship, their own research programs. And part of what that does is it forces them to stay at the cutting edge of what they do, to kind of keep up on what are the problems in their field, what are the techniques, what are the important topics in their field. And then because we don't have graduate students here, right? We don't have much in the way of a support. We have a great support staff, but they're small.
Right.
Most of the faculty are doing that research, those projects alongside midshipmen, like in the Capstone project sequence or in our Trident Scholar program or one of these other things. And part of what that does is it in order to have students be prepared to walk into those kind of projects, we need to make sure they're getting the right things in the curriculum leading up to it, right? So if you're working on cutting edge problems from the Navy in munitions and targeting, you'll know right away that the way we taught gunnery and ordnance in 1910 isn't going to be the right set of prerequisite topics that you need nowadays. You're going to know we're going to need computing and not a slide rule, or whatever it is there.
Yep.
So it's a way, you might say, of tying our education to the real world problems that the Navy, or just, I'll go beyond the Navy and say, are just national security apparatus needs, in whatever context that is.
Right.
And you see it all over the yard. You see it in all different disciplines. There are chemistry faculty who are working on different types of anti-corrosive coatings for ships and for paint.
Right.
And then that kind of makes them think about, like, well, what kind of tools and techniques do I need in my lab to work on that? And then they have to train up the midshipmen in how to use those tools and techniques. And that feedback loop, to come back to our earlier analogy of the feedback loop, you have to be kind of measuring something, right? And monitoring if you're on target here. So that's a way of measuring our relevance.
Sure. Now, you give us a good window into the in-house talent pool that we have, right? This tremendous resource called the faculty, who has an aggressive research agenda as well as a teaching load and the rest. But in pursuing kind of vibrance, relevance to the needs of today's fleet, tomorrow's fleet in particular, especially as we consider great power competition, what other connection points, contacts do we maintain in that national security apparatus, Department of Defense, Department of the Navy? What does that look like? What do those conversations sound like?
Those conversations take on so many different facets. In some cases, it might be leaders from within the DoD that have a connection to the Naval Academy in some way, whether they have an interest perhaps in cybersecurity, or they have an interest in operations research, right?
Sure.
And they may come to us with ideas about these are my initiatives, and I would like to support you in a certain way. But then there's other cases where we have perhaps corporations that have worked in the DoD space before, and they have a new idea or a new piece of equipment they want to try out, and we have that discussion too, and that's an important part of the innovation cycle. Right. We kind of talked a little bit in one of the earlier podcasts about the whole SWAT-C, now termed Ares, right? But that's an example where you may be taking equipment that was built by industry for a different purpose. And now you're exploring different concepts of operation, different ways it could be used, and learning things about that and the process too. So that's a little different format, rather than, I'll say, a little less of a top down, right? But it's a little more of maybe a bottom up or a product driven mentality there.
Sure.
Yeah.
Yeah. So in that sense, our midshipmen become ultimately even better consumers of the products that are
Yeah.
being created
Yeah.
out there because they
Yeah.
better understand the development of these systems and
Right.
so on.
But isn't that what we want in our naval
Absolutely.
officers?
Absolutely.
When you think about it, the Navy is a consumer
Yeah.
of products and technology,
Yeah.
right? And to be a savvy consumer often means,
Yeah.
number one, to be educated about your product,
Right.
and number two, eventually maybe have some say in the requirements
Sure.
for the next generation of those products.
Sure. So in light of that, then, and also because you've been here a while and been so integrally involved, embedded in this process of creating capstone projects and overseeing the capstone program, are we better prepared? If so, how much better prepared for the potential that we see, at least in terms of great power competition?
I think so. I think one of the things that I've seen in the couple decades I've been here,
Yep.
the two big changes I think I've seen in the Capstone program is when I started, it was often the students coming up with a creative idea that they just thought was interesting and fun.
Right.
I remember one year they wanted to make an automatic pool table,
Yeah.
right? The shot billiards in the pockets, and it was a super fun idea, and it
Yeah.
worked, and it was really a blast to work on, right?
Yep.
But what we've seen more and more of recently is the idea that there's a customer or stakeholder that
Right.
we're asking them to engage with. And that's not to say that someone's going to buy the product, right? But it's
Right.
just to say that, don't just go off on your own with a fun idea that you want to work on. Have fun with it. You have to have
Sure.
fun, right? But try to find someone out there who can give you some insight as to what they would want in a product.
Sure.
Right? What are the constraints?
Sure.
How might they use it? And that idea, to go back to your comment about the feedback loop,
Mhm.
that helps ground that capstone process to often the needs of the Navy. It doesn't have to always be the needs of the Navy. It could be the Air Force. It could be NSA. It
Sure.
could be whatever all these different wonderful organizations are, nearby that support us, right?
Yeah.
But
and we have internships too. We send mids to
exactly,
many of
and
these
that's
places.
often the seed of these ideas. They'll go there. They'll go to NSA, for example, for the summer, and they'll come back excited about something.
Yep.
And the summer's not. The summer's short around here in Annapolis, as you know.
Yeah.
Yeah.
Too short for most,
too
right?
short. I know. So they'll often come back and they're like, "Well, I didn't get a chance to finish what I wanted to do,
Right.
but I'm really excited about it." So they come back with more enthusiasm
Yeah.
than actual, accomplishment, I'd say.
Yeah.
But that often
enthusiasm
provides the
finds
seed.
it finds its way into your capstone.
Yeah, finds its way into the capstone.
that's
And then
great.
hopefully that student, because just the nature of our training requirements, tying, all the warfighting concentration and so on, is that, not every student can do an internship. But that student who comes back excited and engaged is going to recruit a team, and they're going to kind of, bring those ideas and those enthusiasm and that what we call domain knowledge. So that what do they see at NSA, or what do they see at Defense Innovation Unit, or wherever it was that they went, and come back with that. So that's really been a change.
Yeah.
And then the second thing that's really changed is the number of the departments. I won't just say the number of midshipmen and the number of projects, but the number of departments that are engaged in that space. In the early days, it was a couple of the engineering programs alone. And now it's, I would say, really most of the departments are, whether that could be language and cultures, that could be political science, that could be physics and mathematics and operations research, are contributing to this this larger capstone day.
Yeah.
And it's great to see, because all those things are super important to what we do.
Yeah. So in an earlier conversation with Provost Fireball, we talked about the future belonging to the generalist, and we talked about the growing interdisciplinary nature of a lot of the research projects here at the Academy. Could you say a word about that? Since you mentioned humanities, social science at the intersection point with science and technology, what does that look like, and why is that so promising?
Well, I think that all real-world research, all real-world products are teams of interdisciplinary experts.
Right.
I don't think you can point to one thing these days that's only made by people with a certain kind of degree. You go to the Lockheed, the Boeings, there's definitely mechanical engineers and aerospace engineers and computer scientists writing the code, and financial analysts trying to find, what makes sense in terms of manufacturing, and chemists making the coding. That's just these academic boundaries or discipline boundaries are They're kind of an artificial thing that we as humans make to help
Right.
wrap our heads around, because you can't know everything about everything.
Sure.
Right. So you have
Sure.
to kind of wall it off a little bit, but it's not natural.
Yeah.
Right. And to go back to the point about being creative, right? I think when you physically create something, you're forced to often move outside of your neatly defined box.
Yeah.
Right. Yeah. Steve Jobs has this thing where he loves to talk about how he took a calligraphy course in college, and everybody was like, "You're wasting your time with that." And then in hindsight, he was so happy he did it, because when they made the fonts on the Mac, everyone said, "These are the most beautiful fonts."
Yeah.
No one had anything like that. So it's those little things that you don't always know at the time.
Sure.
But then when you look back on it, you're like, I know something about that. And even if you don't know everything, maybe you know the right questions to ask.
Sure.
Or you know who to ask
Yeah.
about that. So I think that's one thing I'll say about that. Maybe another great example of how important this interdisciplinary approach is. I love to use the data science major because it's near and dear to my own heart. Talk about it. So what is data science? It's something that kind of came on the scene in some ways in the last like 10 years as a word, but the ideas were always there before. They were called maybe statistics or maybe computing, but the idea is to try to use quantitative or computational tools to study things that weren't always traditionally studied in that way.
Right.
So you can imagine someone who wants to study political science, one way to do it is through stories, through interviews. And that's a very valid approach to it. But another way to do it is to try to collect a lot of data on it.
Yeah. Different type of evidence, objective evidence.
Right. And then when you have that much data, what do you do with it? You're often, computers help, right? So then you have computing. So you have an area, maybe say it's political science, say it's economics, maybe it's history, that you might not traditionally think of as a technical field. Right?
Yeah.
But we had a Trident scholar this last year who wanted to study World War II submarine patrol reports in the Pacific, but he wanted to do it in a data-driven way.
Yeah.
So he got copies of these patrol reports, and there's 300 of them in the Pacific in the years that he was looking at there. And he asked me to help him write some computer code to kind of go through and collect all the keywords that appear in this. So this is hundreds and hundreds and hundreds of pages of documents.
Yeah.
And he wanted to answer questions like, how often is weather a topic of discussion in these patrol reports? Or how often does a particular maintenance issue come up?
Yeah.
Right. And you realize that because these are written by humans, they don't use the same words in the same way every time. So you have to have kind of a fuzzy definition, if you want to say, of what does maintenance mean, right? The word maintenance per se might not appear, but maybe it says, spare parts or repairs or things like that.
Yeah.
So he tried to do a quantitative analysis of what the issues were that came up there. So I think that's a great example of somebody in the humanities trying to have a data-driven, and they're both great. It's, if you only knew the computing part of it, you wouldn't know the right questions to ask.
Sure.
Or you would get an answer and you might not know how to interpret it. So it's that history piece of
history and data science
coming together. And I think that's the right thing in a lot of these fields.
And that's a report. You don't have to be a submariner to find that fascinating.
Exactly.
That would be a brilliant stepping off point for conversations around here, given the role that the submarine community plays here broadly. So that's fun.
And you can imagine that playing out to so many things, right? One of the challenges in data science is that a lot of data is just, it's messy. It's unstructured because people make forms, people do things like that when they weren't thinking about the data age, right?
Yeah.
They construct the form in some way that you're like, I don't know what to do with the information in that if I had to feed it into a computer.
Yeah.
But that bridge in that gap there had to take all that information that's collected and have a more quantitative analysis of it is definitely the way of the future.
And it's a way of disciplining our way of thinking about a lot of things around here. I mean, we're also bringing that same approach to bear on the study of leadership, the field of leadership. A lot of your midshipmen and your faculty members and so on have really helped us think more deliberately about the assessment of what had traditionally been considered kind of a fuzzy thing that you mentioned before. Can you really assess leadership? Can you really measure leadership? Well, when you think about it in terms of individual competencies, knowledge, skills, abilities, and attitudes that constitute leadership, each of those things can be measured pretty carefully.
Yeah. And I'll say it goes the other way around too,
Yeah,
just to compliment you all. I mean, leadership in the Capstone, and we always say the Academy is a leadership lab,
sure.
and that's just one more leadership experience there. You have
Absolutely.
this small team, and sometimes someone just naturally emerges as a leader. Other times, different people on the team are leads for different parts of the project,
Right.
different components. But what does that leadership mean in a technical context?
That's
Maybe
right.
different from what it means in infantry platoon.
Sure.
There's same principles at work, but they
Yeah.
might look different.
Yeah.
And the first time you see them modeled in a different setting, you might not realize that they draw from some of the same
Yeah.
principles.
Well, you used the term first principles before, and I love the
Mhm,
concept.
mhm.
And the first principles of leadership are about good communication, good
Right.
decision making, the team building, the emotional intelligence associated with influencing people to build
Right.
better teams. Absolutely, that's a big, big part of Capstone projects.
They are.
I've always been amazed and thrilled to see how these teams come together
Yeah.
for those presentations. It's a
Yeah.
lot of fun to see. And for those maybe listening in or watching this particular conversation, if you've not been back on the yard for Capstone Day, we try to open those doors
Right.
widely to bring
Right.
people in to observe that. That's one of the more exciting kind of weeks here.
Yeah.
Well, everybody's prepping for those, putting those things out there. That shows how far
Going
along the
back
cutting
to
edge we
the
are.
discussion about faculty research too,
Yeah,
that's an opportunity to model leadership to the
Sure,
midshipmen, right?
sure.
Because, part of what you're trying to do as a scholar is you're trying to really do two things. You're trying to lead in your field, right? So you're trying to lead among some very well-educated peers, some
Yeah.
experts in your field, but you're trying to convince them maybe that your idea has validity or that
Yeah.
it's a good solution. But there's another leadership component is where you're leading the midshipmen who are working on your project and supporting them, right?
Yeah.
So just as you said, those kind of first principles of like, well, I can't expect you to do something if I've never showed you how to
Of
do it.
course.
But then after I've showed you how to do it, I can also hold you to a standard and say,
Right.
did you go back and check the manual? Did you go back and reference your notes?
Right.
Right. So they're just in the same way that, it's maybe looks different than what you'd see in an infantry platoon, but
Sure.
it's the same concepts.
Yeah, the principles are the same.
Yeah,
The first
yeah,
principles.
yeah.
Love that. So, with all that said, let's bring it back around to your principal academic discipline, which is robotics. Right? There's been massive changes over the years there. What are some of the things in that principal area of interest? I know you've got many, data science and all the rest that you've described. But robotics, because this is also Provost Fireball's, early
Right.
principal interest as well, micro robotics
Right.
and so on. We had a conversation about that.
Yeah.
Tell me about your excitement there and where you see that field going. Because if for those of us who think about near peer competition and Ukraine and Russia and everything that's gone on there and how we envision a fight,
Yep.
may look like in the South China Sea, robotics really is at the heart of
Right.
those conversations.
Yeah.
So give us some indication as to what we can expect to see next, what we're seeing right now, and,
Right.
and how you make sense of it all.
Yeah. Well, I think, if anyone's watched the news at all, you could see that Ukraine is a great example, but also events in the Middle East have
Sure.
shown that, this is undoubtedly the future of warfare is just
Yeah.
unmanned, uncrewed systems, whether that be in the air, on land that's coming more slowly, but on the water, under the water, and so on. And that technology has been there for a while, but the industrial base supporting it
Right.
is growing a lot, right? So now it's
Right.
kind of coming out. These are things that started in a lab. These are things that started with
Sure.
academic R&D budgets, right?
Right.
These were research projects 20 years ago,
Right.
but now they're getting to the point where they found a customer in the Navy,
Yeah.
and now it's time to scale up the production.
Sure.
Of these
Very
things.
non-traditional players in this space. Anduril, and
Absolutely.
they're not part of that original
No,
Big
it's
Five.
interesting meeting of some, Silicon Valley types and some
Yeah.
Service Academy types,
Sure.
right? So that's an interesting thing, right? That people who maybe don't spend a lot of time around technology,
Right.
or maybe they haven't been in the military, maybe don't always appreciate that a good idea or a good proof of concept alone is not enough, right?
Right.
That it takes time to scale. People hear about supply chains and the manufacturing base, but it goes beyond that, right? Because you need people to refuel, repair,
Right.
whatever it is, right? So it's a pipeline, truly, in the same way that we talk about training of midshipmen and officers as a pipeline, but so is also building some of this technology. So that's one thing that's really come online more
Right.
so in the last decade or so. From a more, just robotics purely, because you could say that about all shipbuilding and all kinds of other things. I would say from a robotics perspective, a big word that people use now is autonomy.
Right.
So autonomy would mean that to what extent can this device make some of its own decisions?
Right.
Right. And that doesn't always have to mean firing a weapon, but that just means, do I steer this like it's a remote control car, or do I steer it like I'm playing a video game where I'm giving it that low level? I'm not physically there, but there's a human that's controlling this every bit of the way. Right. And that's what a lot of our technology had been, right? But what's really kind of become a new thing is can we enable a little bit more autonomous decision making on board? And to give you a sense why that's so important, the idea why you want to have an uncrewed or unmanned system is to have the operator of it out of harm's way.
Right.
Right. Which means that they have to be physically removed, hopefully quite far away from where the fight's happening. But now that means that you have to communicate or transmit those controls or those commands from the operator to the craft. Yeah. And the more often you have to do that, if you're constantly driving it, the more susceptible you are to any kind of denial, whether it be jamming, whether that be, you have a communication satellite and that gets taken out, whatever it is like that. So you can have the most exquisitely designed drone or the best designed ship. It's only as good as its communication link. Right. And and I know this is about a great power competition or a near peer adversary. And I think everyone's expectation for any conflict in the South China Sea is that the first thing that's going out is GPS, for example. Right. Right. And to a great extent,
down the network.
Yeah. There's going to be all kinds of network attacks, whether that's, at the software level or jamming, whatever it is like that. So autonomy is important in that setting, because without those communication links, if you are actually sending every little command there, then those devices are completely useless. Yeah. Right.
And that's why we see so much about fiber optics these days, right? Since we mentioned Ukraine earlier.
Yeah. They have these drones because they don't have that level of autonomy, right? And because it's susceptible to at the radio frequency level, RF jamming, they have this idea to spool out thousands of feet of fiber cable. And you actually, it's amazing that they can do it. You'd think it would just snag on something. You think the weight of the thousands of feet of even the thinnest cable is heavy. Yeah. So it's amazing that they can do it, but that's really just a stopgap measure on the way to actual autonomy. Right. Right. Because you don't need that. If you could just basically, in the same way that we talked about command at sea, that's what that is, right? You don't have to have the Pentagon literally steering the ship, right? The Pentagon can transmit some high-level guidance to that commander, and then they can make their own decisions within some boundaries, within some set of principles or mission parameters. Yeah. And I think that's where we would like to get with our autonomous systems, and that's where a lot of new developments are happening, and also gets into where maybe AI and robotics are overlapping. People who are maybe not in that space think of those things in some ways like they could be synonymous, but for a long time they were like neighbors, but not actually. Interesting. There's no intersection, right? They were sort of adjacent. Now they're converging. Yeah. This year when I went to the big robotics conference, it was in Atlanta. It rotates all over the world where it is, but it's thousands of papers that are presented, thousands of presentations, and tens of thousands of attendees there. It was the first year that I would say like more than half of the papers were at the intersection of AI and robotics.
Interesting.
Yeah. And you think that might have been around. Not surprising. Well, maybe surprising that it took this long. Yeah, true. And one of the things that why it's maybe been slow to happen is the real world's hard. Sure. We talk about, I'm sure you've talked about large language models or ChatGPT and these kind of tools. Right. Well, language is a lot cleaner than the physics of the world, right? Than ocean currents and roots and rocks on the ground that you have to drive over, and
That's right.
manipulating things with the human hands.
Right.
And the data is not as easy to get. Part of what enabled that whole development in the languages is because the data's, it's almost free. The whole internet is just English language text, and you can just get the whole thing at
Sure.
once for free,
Sure.
right? But it's way harder to collect data from, a robot that's a humanoid robot that's deployed with Marines and carrying it
Yeah.
back and getting all the sensor data from that. It doesn't exist, or if it does,
Right.
there's ones and twos of them. So we
Yeah.
don't have this floodgate of data to train those systems
Yeah.
on. So that's kind of where I think people's minds are in robotics right
Sure.
now.
That's interesting. And to it, going back to the intersection with artificial intelligence, we spent an entire year
Yeah.
in a fairly deep conversation as to what
Mhm.
how we're gonna meet the moment
Mhm.
as AI is changing so many things, and we quickly moved beyond generative AI, large language models, and talked about, especially as we segued into the discussion of a great power competition, the ability not just to build large language models, but these massive data sets from physical imagery,
Right.
which there are many self-imposed constraints
Right. Right.
in the U.S. for doing that, for
Right.
taking these images. Our near-peer competitor, the one we're most concerned about, which is the People's Republic of China, of course,
Yeah.
there aren't those same reservations, which kind of segues into a question that underpins all of this discussion. And I'd be remiss if I didn't bring it up, considering that I work in an ethics center.
Right.
When you use the words autonomy and things like that, I think a lot of people become justifiably a little bit nervous
Mm-hmm.
that we are moving in a direction where we're taking the person out of the loop on this, right? For very good reasons. We want people to be remote from where the shooting is actually happening,
Yeah.
where this destruction occurs. But in many ways, by removing the risk to humans, we also may be removing the agency
Mhm.
that humans bring into the decision cycle, the kill chain.
Yeah.
Could you talk a little bit about the ethics of all of this, especially given your background in robotics?
Yeah. It's a really challenging topic, and
Yeah.
it's a thing where there aren't easy answers there.
Sure.
Right. So you were talking about having the person removed.
Yeah.
So maybe that's a step before saying it's autonomous or autonomy, right? So there's still a human operator in it. And I went to a debate by two ethicists. I think it might have been hosted here at the Stockdale Center, but some years back, and they both raised some interesting issues. And at that time, there was a lot of drone strikes in Yemen and Afghanistan. And one of the points brought up there was that, often when mistakes happen in battle, and I've never been in combat, but it's sort of that fog of war, that idea that information is scarce, that you don't have all the information that you would like to have,
Right.
but that there's a pressure to act. Not a pressure from above, but to protect your personal safety, it's something I think people who have training, have that restraint, but at times maybe you just don't have all the information you need to make a clear decision. You have to act. And that's what it could be: a friendly fire incident. It could be a civilian casualty. It could be whatever. And that the idea of physically removing yourself, your personal danger, your fatigue, from that.
Yep. And the emotions associated. Combat.
Could actually be a positive.
Yep.
For making good decisions on the battlefield. You can have that luxury of restraint when you're not worried about your personal safety. So that's an interesting point that I think I hadn't thought before, because the counterpoint to that is people say, well, you're just going to dehumanize the process of killing, right? It's going to be like a video. It's going to gamify it, right? But maybe that's okay in this case, right? If not to dehumanize it, but to take your own human weaknesses out of it, right?
Yeah. Maybe that's why we so often hear a parallel, fair or unfair, to full self-driving, fully autonomous vehicles, Waymo or Teslas. And I'll fully admit to using the full self-driving capability in my wife's Tesla, and I love it. When people say, well, how can you do that? How can you surrender the control
Right.
associated with driving, it seems really, really scary. And my response to that always is, well, I'm getting older.
Yeah.
And I think my reflexes certainly aren't what they used to be. And I think, I'm not a road rage kind of guy or anything, but I have emotions. I
Yeah.
respond in
Yes.
ways that,
Yeah.
maybe at times inappropriate, where the machine does not. The
Yes.
full self-driving capability has no emotion.
No.
It kind of rationally, logically steps through a series of obstacles simply as that, images that appear. Can that same process be applied to warfighting? And to your point, I think that's where a lot of people land ultimately, that taking the human dynamic out of it certainly has great peril. We can understand how removing human agency from the kill chain is problematic on its face. But if we don't consider the potential upsides, well, then we're not really fully considering the real power of autonomous systems.
I like to say about driving, 90% accidents are caused by people.
Of course. Yeah.
It's very rare that you hear a mechanical failure or something, right? So, but that's not to say that driverless cars are perfect either.
Of course.
I think the important difference there is that when we drive, for the most part, unless you're off-road driving, it's in a more structured environment.
Right.
It's in an environment, I had this project some years ago that was related to driverless cars. It was a Capstone project. It was a competition with students. And one of the things we bought were those orange construction barrels that you see on the side of the road. Often you drive over maybe the Bay Bridge or something before they had those lanes, and they'll put them out there. And those were common obstacles that would be in this competition to test how the vehicle would respond to it. And we tried to buy one on Amazon, and the mids were completely shocked to read that they cost $175 to $200 each.
Yeah.
But the reason for that is there's about a 10-page spec sheet for what is considered safe for the highway. They have to be reflective, visible from a certain distance.
Yeah.
If they you collide with them at a certain speed, they have to brake in a certain way to minimize the damage to your car. You don't think about these things. The lines painted on the road are retroreflective paint, so they light up to your headlights at night. I mean, I know you're a world traveler, and you've probably driven in some countries that are quite different than the United States.
Absolutely.
And, someone will say, well, you won't want to drive there. You should get a driver. And I don't know what you're talking about. And then you go and you realize, whoa, this is different.
Doesn't seem to be any rules here.
Exactly. And that's what's really hard for autonomy. We still haven't totally solved self-driving. There's still problems for all the millions of miles and all the data that we've collected. But that has got to be an easier problem than combat.
Oh, for sure.
And I think that's a big part of the reason why.
That's where the analogy breaks down.
Yes.
Yeah. It's in the level of complexity associated with the task.
It's what we call an unstructured environment.
Yep.
Yeah. It's unlikely that you're going to have training data that's seen that situation before, that circumstance before.
Right.
And that's really complicated. And I think a bit of that is why we're seeing the aerial vehicles, the drones and such, a little further along. The marine vessels a little further along. The ground vehicles definitely not as far along.
Sure.
It's just a little bit more cluttered of a space, right?
Sure.
There's people and obstacles and terrain and all those kind of things. That in the air is it's hard to fly, don't get me wrong, but there's not a lot of things to collide with once you get up there.
Right. Now, with everything we just discussed and all those inherent challenges and limitations of the technology as it currently exists, much of this Great Power Competition series has been directed around the poster that hangs outside of the Stockdale Center. We're at war. Are you doing all you can? Well, returning to that point, is there something that we should be doing, perhaps, to prepare specifically for the fight that is, I don't know if I want to say most likely, but certainly the one that we've been talking about as being most likely, which would be a war at sea in the South China Sea, somewhere around the defense of, for example, Taiwan. Is there something that we should be thinking about? Autonomous systems, surface, subsurface systems, and the preparation for that particular fight.
Yeah. I went to a conference at the Naval Institute earlier in the week, and the topic of conversation there was kind of reconsidering the requirements in the shipbuilding process for autonomous systems, or for not all of them are autonomous, but uncrewed systems.
Very important conversation in this moment.
I think the idea that a lot of these would be attritable assets, so they're designed to be cheap, designed to be expendable, is all the more reason you have to think carefully about kind of scaling up the manufacturing base for them. And in order to do that and adapt quicker, it's maybe also rethinking some of the requirements and acquisition process too. It's not my area of expertise, the DoD acquisition process, but certainly you brought up Anduril, for example, earlier, this corporation, and that's probably like a very different model than the traditional large scale defense contractors.
Sure. Yeah, exquisite systems, very expensive.
Exactly. Right, where it's a multi-decade process to lay out these requirements, and then what you get at the other end might be meet all those requirements, but in the meantime, the requirements may have evolved.
Sure.
Right. So I think it's a mindset shift that's not just in the space of engineering, it's in the space of how the systems will be used in the operational space, but also in the acquisition process and the manufacturing process. And it's just all of that, and I think, because I'll say that we haven't had like a near peer adversary conflict in a long time, I worry sometimes about how quickly we may go through and be able to replenish our stockpile of various weapons. I know the very short conflict recently in Yemen and the Strait of Hormuz, they're pretty quickly went through a pretty large stockpile of munitions there, and it's very small compared to I think what people imagine could happen.
Early on in this series, we had a retired admiral ask us to think about mass, technology, and will. And that first piece, mass, the ability to mass fires, mass unmanned systems and things like that, to focus them in an area, is one of those things that is broadly considered to be an Achilles heel of ours because of our focus on exquisite, very expensive systems.
Right.
Do you think that, well, since we used Anduril, I mean, they've got this concept of Arsenal One, this massive manufacturing facility somewhere near Columbus, Ohio, envisioned. I guess they've already broken ground for this thing. They're going to produce these massive, massive numbers. Is that part of the equation too in the conversations you've been having in regard to technology about our ability to build swarms, for example, of autonomous unmanned systems, these drones? Is that driving our discussions of technology? Swarms and big numbers of yet high tech but inexpensive systems.
Yeah, I think that's really been a focus for a long time. So in the research community, people have been talking about swarms for 20 or 30 years now, and kind of inspired by things like flocks of birds and schools of fish and things of that nature. It's really hard to shoot down a drone.
Right.
It's surprisingly hard. It's an example of how like sometimes smaller is harder, faster, tougher, whatever it is. It's really hard to shoot down a drone. If you kind of look at the profile of it, just look at it at the right angle, it's got to be small to fly. It's got to be light to fly.
Right.
It makes it really difficult to shoot it down.
Yeah.
Now, if you can imagine, there's thousands of them. Even if you could shoot one down, you can't shoot them all down.
Yeah.
So it's kind of a pretty scary threat for an exquisite system, meaning that large ship like that of the future. I have a project this semester with a student that we're trying to think about how we could, I'll say, hack a swarm. Okay. So imagine there's all these, say they're Chinese, for example, but there's all these adversary drones and they're working together as a team and they have some kind of collective behavior. If you could take control of one of them, could you steer the whole swarm off course, or could you make them do something that they wouldn't naturally do by exploiting just their own behavioral tendencies?
Right.
It's a bit like what we do to sheep, right? We make sheep
The rest
go
will
where we
follow.
want them to go because we know we've kind of hacked their brains, and we kind of know if you drag the first one there, they'll all follow along.
Right.
So it's definitely a thing that I think people think about a lot, and it's a hard thing to defend against.
Yeah.
There's one way you could defend against. You could have some kind of electromagnetic thing, but then you risk your own systems
Sure.
in that. And kinetic solution's a tough one too.
Right.
So I don't know.
Now, the kinetic one's so tough that we often say it's much easier to kill the archer than it is to get the arrow.
Right. And then we talked about the idea of the maybe the cyber or the non-kinetic attack, right? So that could be another vector. But now to loop back on our conversation about autonomy, right? So the idea is if this is autonomous, then it maybe doesn't have to be connected to the network,
right?
Or have some kind of communication thing. And if it's not connected to the network, it's not very vulnerable to any kind of cyber attack.
Sure.
So I don't know. It's a really tricky.
Yeah, which just reinforces your point, the interdisciplinary nature of all this.
Mm-hmm.
This is the merge point of many disciplines.
Yeah.
So getting our midshipmen to think in more generalist terms,
Mm-hmm.
be well versed across this broad spectrum of disciplines.
That's right.
That's quite a challenge.
Yeah, it is.
Quite a challenge. So with all of that said about the challenge associated with the work that you do and others on the faculty do here to prepare midshipmen for this future, is there anything about the experience? We mentioned a couple of them, such as internships in the private sector and maybe internships with NSA, the National Security Agency, any number of government agencies that we send to. Are there other experiences that maybe we are offering to midshipmen now that people should know about, should hear more about, or things that you envision that will be coming in the next few years? Because this is the leadership laboratory, the Naval Academy. We use that language all the time.
Right.
And we're talking about those things that complement the classroom, the experiences, whether it be summer training or what have you. What should we know about experiences that complement all of this, existing or envisioned?
Yeah, I think, and that's to always go back to SWAT-SEER areas,
Sure. But it is a great example.
It is a great example. And I think that maybe it in some ways could provide a template for some similar experiences there. One thing that does distinguish us, so we're not MIT, right? In ways that are both good and bad, right? So, but what does distinguish us is we have YPs and we have
the Art Patrol Craft are tremendous
obstacle course, and we have all these things like that can kind of bridge, and we do it to an extent, but to bridge the training side. We talk about the Stribling Walk, for the listeners who don't know, is the walk that connects Bancroft Hall where the mids live, and it's sort of the soul of the military training on campus. And then at the other end of that, we have our academic buildings.
Right.
We talk about making the Stribling Walk shorter, meaning that you get those two sides to row together or be on the same page a little bit more.
But I think they've been trying to crack that code since the 19th century.
And I think we've gotten better at it in the time that I've been here, and I've seen more of
Agreed.
that. And I think there's a lot here that connects those two. But maybe there's other experiences like that we can bring some of that academic side of things closer to those training experiences. The YPs being one example.
Yeah. So another vote for rowing together.
Yeah.
A lot of people around here are using that language.
Yeah.
I think a lot of progress, because I think we've been here almost exactly the same amount of time.
Yeah.
And in that time, I'd like to think that we have broken down a lot of those, pick your cliche, stovepipes.
Yes. Yeah, I think so.
And I think the near term is even more promising for some of those things, just based on the leadership that we have around here.
Yeah.
It's all very, very, very promising. And maybe even more promising from your conversation today that I've learned are the relationships that we're forging with the fleet, operating forces, with the private industry, and all these things. Is there anything that we haven't discussed on that front that you're working on now or are excited about that we should know about?
Well, we have a lot of discussion going on right now with DARPA, the Defense Advanced Research Project Agency. And if you don't know very much about DARPA, they like to work on really, really hard problems. They call them DARPA hard.
DARPA hard.
With creative people. with
Yep.
creative young people. So we are trying to explore how the Naval Academy could play a role in that. Again, we might not have the scale of the resources of a place like MIT, but what we do have is we have people that are knowledgeable about, the D and DARPA is for Defense
Right.
Advanced Research Project Agency. So we have people that have some operational experience and interest in that space, but also have the creativity and the technical mindset. So we're trying to explore how we could be a partner with DARPA in some of those experiences. It's early still in our discussion, but
Yeah.
that's something that's coming on. We also have some good discussions going on with the Uniformed Services University, which is a place where most Navy and Marine Corps doctors go to med school, as well as from the other armed services too. One of their huge initiatives is the term digital twinning is thrown around a lot these days, but it just means making an extremely high fidelity simulation of an environment so that you can use it maybe for training, maybe for studying a more efficient flow. So you can imagine the deck of an aircraft carrier. If we had a perfect simulation of how those planes move around, we could do training with it without risking an accident. We could maybe design a better protocol or algorithm for how to launch, in a tighter window. USU wants to explore something like that for the hospital environment.
That's great.
And some of our researchers are going out there to meet with them and learn a little bit more about their efforts and try to bridge that gap a little bit there too.
Boy, I love that. And it's in no way surprising, because if I think of all the products and services that the Stockdale Center has created over the course of the past few years, I think of our augmented reality simulations for ethics, the broad interest there has been well beyond the Naval Academy, other service academies, war colleges around the world. I had an opportunity to kind of trot those things out in places as far away as Sibiu, Romania, to their conference there at their kind of service academy, down to Cartagena, Colombia.
Yeah.
Everybody's interested in that. And I can only imagine the conversations you're having in the technical part of the yard about how we might contribute to that for medical and any other communities that are kind of pushing hard.
NSA is always a partner for us there. I believe the Provost is headed out that way to have some good discussions right now. As you know, we have a cyber major here, and they kind of maintain a certification with NSA, and both because of our proximity to that and also its importance to warfighting. I mean, it's a great synergy there. And we're trying to explore other connections that we might make with things like quantum computing and quantum sensing and those kind of advanced technologies that maybe a partner like that could help us support there. And we always have a continuing strong relationship with the Office of Naval Research. And, who better to help us align our, our curriculum and our interests and our faculty skill set with the needs of the Navy than the Office of Naval Research, who really seeds that R&D process for the Navy, whether that's, as we talked about, anti-corrosive paint coatings or, lightweight aircraft wings, whatever it is. They really have played a huge role in supporting the Naval Academy's research enterprise. So we always want to keep that relationship healthy.
Of course.
Yeah.
Of course. Yeah. That is exciting.
Yeah.
And I can only imagine how excited midshipmen are that they're not doing things that are merely interesting from a narrow, immediate academic purpose, but rather things that connect into the real world and connection points to exciting work done at agencies, affiliated agencies. So, Dr. Esposito, I mean, you've kind of opened our eyes to a whole lot of really interesting work being done here. We appreciate your time on this. Certainly appreciate your contributions to this larger conversation. This would not be a full conversation on great power competition without diving into the things that you have some clear and deep expertise in. So thanks.
Thank you. It's a pleasure.